So let's continue graphing the rest of the trigonometric functions. So let's start off with the tangent curve. So what exactly does this tangent look like? So one of the things that we have to consider is that tangent of x is equal to sine of x over cosine of x. Now, because we have a denominator now this kind of turns the trig function into kind of like a rational form with the cosine of x not being able to equal to 0. Okay, so actually what's going to happen is that wherever the cosine is 0, that's where you're going to have these vertical asymptotes, because as we recall from rational functions, where the denominator cannot be 0, where the denominator equals 0, you're going to get these vertical asymptotes. Now let's recall our unit circle. We're going to kind of do the same exact thing. So look at 0, pi, pi over 2, pi, 3 pi over 2, and then 2 pi. But what you're going to see is that the tangent curve is going to be kind of funky. So I'll definitely graph the whole thing. But you'll see why this is not going to be as useful as it was before. So if I take a look at all these points, so 0, 0, oh no, that's wrong, 1, 0, 0, 1, negative 1, 0, 0, negative 1. If I take a look at all of that, so let's go ahead and take a look at what happens at 0 radians. So at 0 radians, we take up the sine and the cosine, right? That's the y over the x, right? Because this is x and this is y, you're just going to get 0. So the tangent curve is going to be at 0. Then when you look at pi over 2, what's happening here is that you end up getting, again, y over 0. So then at pi over 2, you end up getting an asymptote. And then if you keep going, like if you go over to pi, you notice that you're going to end up getting another 0. So, and then you go to 3 pi over 2, and then you end up getting another asymptote. So this seems like it's not really quite working for us. Because, I mean, obviously the graph is not just a point. So one of the things that we might want to consider is looking halfway between 0 and pi over 2. So pi over 4, what exactly is happening at pi over 4? Well, the values for pi over 4 is going to be square root of 2 over 2, square root of 2 over 2. And if you think about the sine over the cosine, that's just going to be equal to 1. So actually, if we take into account the pi over 4, you end up getting this point, this 1 in here. Okay? And we can do the same thing here. So if we take a look at 3 pi over 4, right, which is going to be the negative square root of 2 over 2, square root of 2 over 2, that's going to give me a negative 1. So you can see that at 3 pi over 4, we end up getting a negative 1. And then we can now look at 4 pi over 5 pi over 4. And this guy is going to be both negative square root of 2 over 2, negative square root of 2 over 2. So we're back at a positive 1 at 5 pi over 4. So you start looking at the fourth, every 4, and basically what you start seeing is this little pattern. Kind of like an x cubed. But now these things are hugging the asymptotes. And now what I'm going to do is I'm going to do the opposite, because we know that this is kind of like a period, right? So I'm going to go backwards and go to negative pi over 4 and negative pi over 2. So at negative pi over 2, that's going to be down here, negative pi over 2, right? Because I'm going the opposite direction, and that's going to be undefined also. And then if I look at negative pi over 4, which is this one, which is equivalent to 7 pi over 4, you're going to get square root of 2 over 2, negative square root of 2 over 2. So that's going to be a negative. So again, you see this pattern. And these guys are going to be, oh, that looks so ugly. See if I can make this a little nicer. Get a little closer. Okay, so, okay. So essentially what we end up getting is these weird curves. Okay, so if I were to continue on also, you're probably going to get something that looks like this, going upward and then going downward again with another set of asymptotes. So this is basically what the tangent curve is going to look like. All right, so let's analyze this a little bit. So this tangent curve looks a lot like the x cubed curve. Okay, so if we take one period of this, it kind of looks a lot with the x cubed curve. It also has two pairs of asymptotes in here. So you have an asymptote here at pi over 2, at negative pi over 2, and also another set of asymptotes at positive pi over 2. All right. So let's take a look at what exactly is happening here. So for one, the stretching factor is just going to be absolute value of a. There's actually no amplitude here. This one is not really a wave, so there's not really an amplitude, but there is a stretching factor if you have a factor of a. The period now is not 2 pi over b. Now it's pi over b. Why is it pi? Well, notice how many times it repeats. So notice that one whole period is between negative pi over 2 and pi over 2. So how far is pi over 2 from negative pi over 2? Well, this is just pi over 2 plus pi over 2, which is 2 pi over 2, which is pi. So it actually completes one full cycle every pi units. Okay, so that's why our period is going to be pi over b. The domain of the function of tangent of x is all real numbers except where x is not equal to pi over 2 plus pi k. So the reason why this is, notice that if I start at pi over 2 here, this second blue line, and I add a pi unit here, I get the other asymptote. So it's all x values except this thing. So usually we would write this in set builder notation. All values of x such that x is not equal to pi over 2 plus pi k. Later on, we will be able to find domains of things that are really weird, but we'll look at that later. The range here is negative infinity to positive infinity, so it just keeps going forever, regardless of the transformation. The equation of the asymptotes, like I said before, is x equals pi over 2 plus pi k. And tangent is an odd function, okay, because it resembles a lot of the cubic function. So again, later on, we'll find the equation of the asymptotes. Now, how do we graph them? Well, one of the things that you have to pay attention to is some of the key features of the tangent curve. So notice there's a reason why I highlighted all the thing in blue and the thing in yellow. So notice that this is going to be the key features. Asymptote at negative pi over 2. Point at negative pi over 4, negative 1, which is that lowest one. Point at 0, 0, which is right at the origin. Point at pi over 4, 1. And then asymptote at x equals pi over 2. So these are the key features that you need to take a look at. This is what you're going to be stretching, compressing, and everything is basically the same thing as graphing sine and cosine, except that now the period will be pi over b. Now again, one of the things that you might want to consider doing is rearranging the tangent graph. Okay, again, this maybe making it in this format where f of x is equal to a tangent. We're going to pull out the b, x minus c over b plus d. So you still want to do the same thing. Okay, so this is going to be the phase shift, and this is going to be the new period. Okay. So this is something that you might also want to consider doing exactly the same thing. Again, the only thing that's different now is that our period is going to be pi over b, not 2 pi over b. All right, so let's go ahead and do some examples. Okay, so let's graph the following. Okay, so you see that we got a stretch factor of 2 and a phase shift of pi over 4. Luckily, the period hasn't changed. We're just changing everything pi over 4 units. So let's deal with the pi over 4 first. So we got the phase shift. Is pi over 4 units. And this is it's negative, so it's going over to the right. So if you think about the graph of the tangent curve, so let me just draw one whole period. You're at negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. Then our key points, -1, 0, and then 1. And this is kind of what the general tangent curve looks like. That's one period of the tangent curve. Remember that it does continue to repeat. And one of the things that we want to do is shift everything pi over 4 units over. Okay? So let's go ahead and do that. So what I'm doing is that I'm shifting pi over 4 units over. So I'm moving this way. So I'm adding the pi over 4. Okay, so adding pi over 4. Okay, so right now I'm at negative pi over 2. So every single one of them are going to be moving over pi over 4 units. Okay, notice that everything's already in fourths, right? So we can kind of just do it this way. We can start off, okay, where my first asymptote, which is negative pi over 2. And then we have negative pi over 4. Then positive, then 0, then pi over 4, and then pi over 2. So these are my 5 key features, and what I'm doing is I'm shifting this pi over 4 units over. All right, so you can just use your calculator if you want to. So it's just kind of how we did it before, or you can just find the least common denominator. So you're gonna get, for this guy, negative pi over 4. This one, you see that they cancel out, so it's 0. Okay. Oh, I forgot the pi over 4 here. This guy's going to be at pi over 4. This is going to be at pi over 2. This is going to be at 3 pi over 4. Okay. So now what we did is that we found our new points after everything has been shifted. So now no longer am I going to have this pi over 2, pi over 4, any of that stuff. Now you're going to be at negative pi over 4, 0, pi over 4, pi over 2, and 3 pi over 4. Okay, so let me go ahead and draw this guy. So remember, the first one is my asymptote. Then the next one's at -1. My next one's at 0. My next one's at +1. And then last one is an asymptote. So my graph kind of looks like that. And now finally you see this 2 here, that's going to be a factor of 2. So I'm going to multiply everything by 2. So it's basically the same exact graph, but now everything is shifted from 1 all the way to 2. So negative pi over 4, 0, pi over 4, pi over 2, 3 pi over 4. So now this one, instead of 1, is going to be at -2. This one's going to be at 0, and the other one's going to be at 2. So everything is a stretched factor of 2. Right? So this is going to be my solution, this guy. All right. Okay. So one of the other things that you could have done is you can just look at the asymptotes, move the asymptotes over to pi over 4 units, and then find the midpoints as well. So you could have also done that, find the midpoints of all these guys. All right, let's go ahead and do this other problem. So now we have a phase shift, and we got a flipping, and then we also got a vertical displacement. So let's start off by changing this guy up. So it's going to be negative tangent. Pull out the pi. And then you got to get an x plus. So since I'm pulling out the pi, this is going to be 1/2 minus 1. Okay. So let's take care of the phase shift and the new period. So let's start off with the new period. So the new period will be pi over b. Okay, so b in this case is pi. This is this guy. It's pi over pi, which gives me 1. Okay, so this whole thing is going to complete one cycle in 1 unit. Okay. All right. And now my phase shift. This is going to be 1/2 units over. So 1/2 units to the left. I had to think about that one. All right, so now how are we going to get our period? So now remember, our tangent graph looks like this. So here is negative pi over 2, pi over 2. And the graph looks kind of like that. Now, the thing here about the new period is that it's very different than the way that we had it before. Typically, with the sine and the cosine, it would be from 0 to whatever that period is. Now, this one doesn't start at the origin. But this is what we can do. Well, we know that the period of a tangent curve from here to here is pi. So notice that in order for me to know the equation of the asymptotes, I take this pi and divide it by 2 because this thing is halfway between these two, right? The whole thing, there's some sort of symmetry here. This is an odd function, right? So you got some sort of, so half of it is going to go on this side, the other half is going to go on the other side. So that's why you got negative pi over 2 and pi over 2. So now what we're saying is that, okay, well, now we got the same thing, but now my new period is going to be 1. So if I need half and half, that means my new asymptotes are going to be from negative 1/2 to 1/2. Okay, so that means it's going to, my starting point is going to be at negative 1/2. That's where my first asymptote is at. And my ending point is going to be at positive 1/2. That will give me a full period of 1. Okay. So that's what that's going to give me. And now what I'm going to do, maybe I should write ending over here. And it will be at 1/2. All right, and now what I have to do is use a phase shift. So I'm going to move everything over 1/2 units. So what I'm going to do is I'm going to take this guy, units to the left. That means I'm subtracting the 1/2. So I'm going to subtract 1/2 to this guy and subtract 1/2 to this guy. This one is corresponding with the phase shift. Okay, so this is going to be a negative 1, and this is just going to be 0. Okay, so the equation of the asymptotes, or the asymptote is going to be starting at negative 1 all the way to 0. So let's go ahead and graph that. So it's going to start at negative 1, and it's going to end at 0. Okay, and now all we really got to do is find the midway points. So half of negative 1 and 0, halfway is just negative 1/2. Halfway between negative 1 and negative 1/2. So I'm going to take halfway here. So that's going to give me negative 1 plus negative 1 over 2 divided by 2. That's going to give me negative 3/4. And then halfway between this one and this one will just give me negative 1/4. Okay, so you can see here, here's my asymptote. So I have an asymptote here. And actually this is where the y-axis is at. So there's actually an asymptote there too. Minus positive 1 and 1. And actually, oh no, let's just keep it up like that. 1 and 1. And you just can do this. So this is what the graph looks like. Okay. So I just did the period change and I did the phase shift all at once. Okay. And now what we want to do is fix this negative. This negative is just going to flip the graph. So I'm just going to flip. So negative 1/4, negative 1/2, negative 3/4, negative 1. So asymptote's still in play. Everything is swapped. So now this point, so that was at negative 1, is going to be a positive 1. And this guy that was at positive 1 is now going to be a negative 1. So now the graph looks the other way around. Okay. And now finally what we're going to do is bring it down 1. So that's where that negative comes from. So 0, negative 1/4, negative 1/2, negative 3/4, negative 1, asymptote here, asymptote here. So everything's going to be shifted down 1. So I'm going to need a negative 1 and a negative 2. So this guy's now going to be at 0. This guy's now going to be at negative 1. And now this guy's now going to be at negative 2. So the graph looks something like this. Okay. And that's going to be my answer. Okay. So yes, here the only subtle thing is that when you find your period, after you find your period, it'll be a really good exercise to just divide it in half, and that's where both of your equations of the asymptotes will be. So let me make a little note. For tangent, when you find the new period, divide it by half to find asymptotes. And notice that, because we knew that the period was 1, so we divided it by half, so now that means my asymptotes were going to be at negative, not that one, negative 1/2 and 1/2, because 1/2 and 1/2, and negative 1/2 and 1/2 is just going to give you that whole one unit of the period.